Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone, welcome and thank you for joining us for today's Oxygen Talk brought to you by the Oxygen Alliance. My name is Daphne Makela. I'm a biomedical engineer and product developer under the Open O2 initiative under Global Health Informatics Institute, and I'm very excited to be your host today. The Oxygen Talk is a virtual meeting where we discuss various topics related to medical oxygen and oxygen devices. I am hosting this call from Lilongwe, Malawi, and I would like to know where you're joining us from by typing in your name and location in the chat. If you want to be added to our emailing list and get notifications of upcoming events by the Oxygen Alliance, please type your email in the chat. We promise that we'll be starting a session on medical imaging this week and specifically on X-rays, but unfortunately, due to circumstances beyond our control, we're not able to do that today, but be on the lookout and join our emailing list so that you know when that starts, when that series begins. But for today, we have another informative presentation from Oxygen Alliance and Open O2 biomedical engineers. In today's session, we'll have a detailed presentation on the understanding of the engineering behind nebulizer technology. And our engineers are Victor Nzembe, Lloyd Kayambe, and Ketia Nsambu. So we'll be diving into the types of nebulizers, their mechanisms and applications, as well as maintenance and troubleshooting skills. I encourage you to take notes as we look forward to hearing your questions and comments at the end of the presentation. So without taking much of the time, let me hand over the floor to Victor Nzembe to start off the presentation. Over to you, Victor.
Thank you. As already mentioned, my name is Victor Nzembe, and I am a biomedical engineer for Oxygen Alliance. And today I'm going to take you through the first part of our today's talk, that is on the engineering behind nebulizer technology. So just a brief overview of what we're going to cover in today's talk. So firstly, we'll have an introduction to nebulizers. And then we'll look into the different types of nebulizers, under which we'll cover the jet nebulizers, the ultrasonic nebulizers, the mesh nebulizers. And then we'll go on to looking on the maintenance of these nebulizers as well as their safety practices. So to begin with, let's have an introduction to nebulizers. So a nebulizer basically is one of the devices used to deliver medications to patients. So this device turns liquid medications into fine mist or an aerosol. The device is used to administer medications directly to the lungs. So if a patient has difficulties to take in liquid medications, they use the nebulizer in order to take the medications directly to the lungs. So let's look into some of the clinical applications of these devices. So one of the applications is COPD. So COPD just stands for chronic obstructive pulmonary diseases. And these conditions causes obstructive airflows and breathing difficulties. So for such patients, for them to take in liquid medications, it can be a problem. As such, they might use the nebulizer to take the medications directly in form of a mist. The other condition is asthma. So for these patients, they use medication. They can take medications that cannot be delivered using inhalers. As we know, most asthmatic patients, they use inhalers to take in medications, but some of these medications cannot be delivered using inhalers. For example, antibiotics. So as such, they resort to nebulizers. Then the last condition is fibrosis. So under fibrosis, we have two types. It can be cystic or pulmonary. So these conditions actually interferes with the breathing system by affecting the lungs. So cystic fibrosis can cause mucus production in the lung tissue, whereas pulmonary fibrosis causes tissue scarring. Now, just an overview of the types of nebulizers. So the first type is the jet nebulizer, and then we also have the ultrasonic nebulizer, And lastly, we have the mesh nebulizer. So I'll take you through the first type, and my colleague will take you through the remaining two types. So let's talk of the jet nebulizer. So the jet nebulizer is a medical device that uses compressed air to break down liquid medications into fine mist. So what separates this nebulizer from the other types is that it actually uses compressed air. So this air is supplied at a flow rate of between 2 and 10 liters per minute. So any flow from 2 to 10 liters per minute is convenient for the operation of a jet nebulizer. Just take note that this one is the most common and widely used type of nebulizer other than the other two. To the right of the slide, we have a picture of a typical jet nebulizer. Now let's look at the typical jet nebulizer assembly. So in the figure there, you can see a diagram that shows a typical jet nebulizer assembly. So basically, the device consists of two parts. It has a nebulizer kit and then the compressor. So the compressor is the main unit of the device assembly. In the next sections, we are going to look into details on the two main parts, which are the nebulizer kit and the compressor unit. So to begin with, let's look at the compressor. So as I mentioned, the compressor is the main unit of this device assembly. And this compressor compresses ambient air to a high pressure. And basically, jet nebulizers have compressors that have an output pressure ranging from 30 to 50 psi. So in the figure there are external parts of the compressor. So we have the air openings. So the air openings are the ones which allows ambient air to enter the compressor. Then we also have a filter. So the filter actually traps contaminants as well as dust particles that are present in the air before it can be delivered to the nebulizer kit. Then we also have a power switch. So the power switch is used to turn the compressor on and off. Then we also have the power cord. So this one supplies power to the compressor after connecting it to the mains. Then we also have the air outlet. So that is the port where you connect the tubing that takes the pressurized air to the nebulizer kit. So in the diagram there, we have a picture of the compressor assembly. So the compressor basically is made up of a motor connected to a piston. So when the motor is rotating, it pushes the piston back and forth. The pushing of the piston back and forth causes ambient air to be sucked in, and then it is compressed and pumped out of the compressor using a tubing through the air outlet, as we saw in the previous diagram. So the other part, as mentioned, is the nebulizer kit. So generally, this is where now the nebulization takes place. So the nebulizer kit is made up of different parts. So number one, which is the major part, is the nebulization chamber. So the nebulization chamber actually holds and breaks the liquid medication into mist. We also have a hose. So a hose or a tubing actually is the one which is connected between the compressor and the nebulizer cap. So it takes compressed air from the compressor to the nebulizer cap. Then we also have an air inlet, which is located at the bottom of the nebulizer cap. So this one takes in the compressed air into the nebulization chamber. Then we also have a face mask or mouthpiece. So this one is used for patient inhalation. So for the patient to take in the nebulized medicine or the mist, they use a face mask or a mouthpiece. And lastly, we have a face mask or mouthpiece interface. So this one is located at the top of the nebulizer cap. So to the right of the slides, we have diagrams showing some of these parts. So we have a face mask or mouthpiece interface pointed on the top of the nebulizer cap. And then we have the face mask and then the hose. Now let's look at the operation of a jet nebulizer. So for the jet nebulizer, as I mentioned, it uses compressed air. So the compressed air from the compressor is forced through a structure called a jet. And at the top of the jet is a small cavity as it is commonly called a venturi nozzle. So actually, the device uses the venturi effect, whereby air pressure is reduced as it passes through the small gap, while the velocity is increased. So the reduction in pressure at the top or the jet or at the venturi nozzle causes the liquid medication to be sucked up through a feeding tube from the reservoir. And the interaction between the sucked up medication as well as the high velocity air breaks the liquid medication into small droplets. And that process is called primary atomization, as shown in the diagram. Then after that, the droplets hit the baffle, as shown in the diagram, and that baffle is the one which creates smaller particles that can be delivered to the patient. Apart from that, the baffle also makes sure that larger particles are not delivered to the patient. So all the larger particles are returned to the reserve. So that process is called the secondary generation, whereby the baffle now only ensures that smaller particles passes through the patient. Also take note that the baffle may be fixed or removable. So some models have the baffle fixed, whereas other models can have a removable baffle. So after that, then we have the connecting tube. So that's where you can actually connect the patient interface. That is either a face mask or a mouthpiece. So under the same operation of a jet nebulizer, let's talk also of the gas and medication mixing. How do the gas and medication mix? So depending on the nebulizer nozzle design, the liquid medication and gas interaction may be internal or external. So in the diagram there, we have to the left internal interaction and to the right external interaction. So for the internal interaction, it means that the gas and the liquid interact before they leave the nozzle and then hit the baffle. Whereas for the external interaction, actually what happens is that the liquid medication as well as the gas leave the nozzle face, then they interact and then hit the baffle. Now let's talk of the different categories of jet nebulizers. So it is important to note that there is actually one major category, which is the conventional nebulizer, because the others are just improvements on the conventional nebulizer. So the conventional nebulizer requires continuous delivery of mist over the treatment duration. So it means if the patient wants a treatment duration of 5 minutes, the mist has to be produced continuously for 5 minutes. And this nebulizer actually has a higher medication dose because most of the medication is dosed during exhalation or when the patient breathes out. Then the other type is the jet nebulizer with a collection bag. So the only difference between this one and the conventional nebulizer is that with this one, it can collect mist released during expiration or when the patient is breathing out in a bag. So while the patient is taking in the mist, and then when they breathe out, the mist that is produced is collected in a bag instead of it just being lost. So these collected aerosols can be administered through a one-way valve between the mouthpiece and the collection bag. The third type is the breath-enhanced jet nebulizer. So the breath-enhanced jet nebulizer releases more mist during inspiration or when the patient is breathing in through one-way valves in the mouthpiece. So this one actually it has one-way valves in the mouthpiece. So the patient actually can take in more mist. So it can increase mist delivery to the patient. So to the right there at the top, we have a breath-enhanced jet nebulizer. And then the last one is the breath-actuated jet nebulizer. So with this one, it's the most advanced because it actually senses patients' inspiratory flow and then produces mist only during inspiration. So it detects when the patient is breathing in, and then during that time, it can produce mist and deliver to the patient. So these nebulizers, they have an actuator button at the top that moves up and down. So when the patient inhales, the button moves down to start mist generation. When the patient exhales, the button moves back to its closed position, and this stops mist generation. So let's look at the technical factors that affect the performance of jet nebulizers. So the first factor is the fill volume. So the fill volume is just the amount of liquid medication that is in the reservoir. So the higher the fill volume, the greater the nebulization rate. However, if the fill volume exceeds the recommended demarcations, it can also be a problem for the nebulization process. The second factor is the solution characteristics. So here we're talking about the medication itself. Talk of the density of the medication, the viscosity, as well as the surface tension. So generally, a higher dense medication will reduce the nebulization rate, as well as a viscous medication will also reduce the nebulization rate. Similarly, for the surface tension, if the medication has greater surface tension forces, it will be hard to break down the medications into smaller droplets. Then the other factor is the model. So as we looked at the different categories of the nebulizers, we might have noticed that different models have different performances. So let's say for the breath-actuated nebulizers, they are more effective and efficient than the conventional nebulizers. Then we also have the operating pressure. So the operating pressure, we're talking of the air pressure itself. So if the air pressure is low, the nebulization rate will also be low. Then finally, we have the air flow rate. So we say the air flow rate can range from 2 to 10 liters per minute. So if the flow rate is on the lower side, the nebulization rate will also be lower. Similarly, if it's on the higher side, the nebulization rate will also be high. So let's look into the advantages and disadvantages of jet nebulizers. So on the advantage side, firstly, the jet nebulizers are effective in delivering medications that cannot be delivered with inhalers. So we talked of antibiotics. You cannot deliver antibiotics using inhalers. As such, you resort to jet nebulizers. Another advantage is improved designs reduces amount of wasted medication. So we talked of designs like the jet nebulizer with the collection bag, as well as the breath-actuated jet nebulizers. So these ones actually reduces the amount of wasted medication during treatment. Then lastly, it is very easy to use. So the jet nebulizer is very easy to use as compared to the other types. But on the disadvantage side, we have the noisy part. So the use of the compressor itself makes the jet nebulizers produce more noise. And the other advantage is that it requires electrical source. So if you want to use the jet nebulizer, it means you have to plug the compressor into the main socket. So this is actually a disadvantage because for the other types, you can actually use a battery to run the nebulizer. That's all on the advantages and disadvantages. Reaching this extent, we have pause. So I will hand it over to the host to take us through the pause. Over to you, Daphne.
Okay, so we'll skip the pause for now, and the next presenter can go. Thank you.
Hi, thank you so much, Daphne. And thank you, Victor, for the nice introduction and presentation. My name is Fred Kayembe. I am a biomedical engineer for Oxygen Alliance. So I will continue where my colleague left off by discussing the other two types of nebulizers. That is the ultrasonic and the mesh nebulizers. So unlike the jet nebulizers, ultrasonic nebulizers use high-frequency sound waves to generate the mist for the medication delivery. So on your right, you can see an image of a typical ultrasound nebulizer. So these devices come in various sizes, but they all operate using the same principle for high-frequency sound waves to create the mist for the patient to inhale. Some models are battery-powered, while others actually rely on AC from a wall socket. So there are actually a few key components that actually ensure the functionality of these devices. So let us explore these key components. So the first major component is the piezoelectric transducer. So this device, the piezoelectric transducer, converts electrical signals into mechanical vibrations using a piezoelectric effect. So that is when an electrical signal is applied to the piezoelectric material, it vibrates, converting the electrical energy into mechanical vibration. So on the image, to your right, you can see the picture of where the piezoelectric element is actually located on the ultrasonic nebulizer. So when you open the unit, you can find the piezoelectric element underneath this position. So you can actually observe that the piezoelectric element is actually surrounded by a heatsink. So actually, this heatsink helps to dissipate the heat that is generated when these mechanical vibrations are being generated by the piezoelectric element. The other component is a fan. So a fan it pushes out the mist that has been produced in the nebulizing chamber into the mouthpiece or mask that the patient is wearing. So in this type of ultrasonic nebulizer, the airflow is actually controlled by a flap. So you can see an image on the bottom. That's where I've labeled airflow outlet. That's a flap that controls the airflow. And there is actually a control knob on top, which I'll show you later, that adjusts the opening of this flap, thereby regulating the amount of airflow that has been pushed, that pushes the medication. Some models don't have a fan. They just rely on the patient's inhalation to draw the mist from the nebulization chamber. So just take note of this. The next component of the ultrasonic nebulizer is the control board. So this regulates the amount of vibration that the piezoelectric element is making. So on the image, to your right, you can see two circuit boards that are typically found in an ultrasonic nebulizer. So there is a power circuit board and there is a control board. So the power circuit board it just provides power to the main control board and the piezoelectric device. Yeah, so these are just the major boards that you can typically find in the ultrasonic nebulizer. Another component is an air filter. So this filter, as you can see, is located at the bottom of the device. Ensures that the air that is drawn by the fan is free of dust or any other contaminants. So it filters out the impurities and protects the internal components from accumulating dust. It also prevents contaminants from being inhaled by the patient. So another part that is important is the control panel. So in a typical ultrasonic nebulizer offers some level of control over the parameters such as the airflow, the particle size, or the mist itself, and actually the nebulization timing. So for this specific model, there is a control panel on top with knobs that allow you to adjust these parameters. So like the one that I was talking about, the fan. So you can see the control knob on top is the one that controls that flap and ensures that an airflow that you want is pushing out the mist. And the other knobs control the timing and the fog volume, that is the size of the particles. So actually the control panel also has LED lights or indicators that indicate the level of the cooling water and the power status of the machine. So I will explain more about this cooling water in the next slides. All right, so let us now explore how all these components work together to produce the actual mist. So on your right is an illustration of the entire ultrasonic nebulization setup. So the nebulization cap, which contains the liquid medication, is placed on top of a small amount of water that is in contact with the ultrasonic device or the piezoelectric element. So you can see on the image I've labeled it a vibrator. So this is actually the cooling water that I was talking about. So typically a high frequency electrical signal that is between 1.2 to 2.4 megahertz, is sent from the control circuit board to the piezoelectric crystal, causing it to vibrate at the same frequency that it has been sent. So as it vibrates, it transfers the energy to the water above the piezoelectric element. So when the energy is transferred to the liquid, when this energy is being transferred to the water, it is then transferred to the medication itself. So actually, these vibrations that has been transferred into the medication creates areas of high and low pressure within the liquid, within the medication. So these areas of high and low pressures causes cavitation within the medication, meaning that tiny bubbles are formed within the medication. So when these bubbles collapse, they release the energy and eject tiny drops of the medication at the surface, hence creating the mist itself. So actually, the frequency that is being applied to the piezoelectric crystal is crucial because it determines the size of the aerosol droplets or the size of particles that are being produced in the mist. So the higher the frequency, the smaller the droplets. Yeah, so that's basically how the ultrasonic nebulizer works. So these ultrasonic nebulizers can be divided into two types. There is one that is direct contact ultrasonic nebulizer, and the other one is an ultrasonic nebulizer with a water interface. So in the image on the left, you can see the ultrasonic device that has a water interface. So as I was saying previously, that the piezoelectric element generates heat when it vibrates. So the main reason of using the water interface in some models is to absorb the heat that is being generated by the piezoelectric element. So this is important to ensure that heat sensitive medication can be delivered safely without being degraded by the heat that is being produced. Yeah, so these are the actually two types of ultrasonic nebulizers that you can find. So just looking at the advantage and disadvantage of the ultrasonic nebulizers. So on the positive side, we have the silent operation. So they are much quieter than the jet nebulizers because they don't use any compressor to generate the mist. So that's why they are so silent. And the other advantage is they can be battery operated, meaning that they are portable for use. So you can use them anywhere other than other nebulizers that require power always. So the other disadvantage, the disadvantage side is that as I said, they generate heat because of the vibration of the ultrasonic piezoelectric material. So this may slightly warm the medication, which can be problematic for heat-sensitive drugs. So yeah, that's the major disadvantage of these ultrasonic nebulizers. And another disadvantage is limited medication compatibilities. So they are not suitable for all types of medication, meaning that medication with viscous solutions cannot efficiently be nebulized by these by the ultrasonic nebulizers. So that's another disadvantage of these ultrasonic nebulizers. So the other type of nebulizers are the mesh nebulizers. So these are quite similar to the ultrasonic in the sense that they also use a piezoelectric element. The difference is that mesh nebulizers operate by forcing the medication through a mesh. So actually, this mesh contains thousands of tiny holes that transform the liquid into fine particles. And that forms the mist itself. So actually on this type of nebulizers, there are 2 types based on the mechanism that they use to to produce the mist. So they are vibrating mesh type, and their static mesh type. So let's start exploring on the vibrating mesh type. So the vibrating mesh type consists of the piezoelectric element that is coupled with a mesh, this mesh that I was talking about that contains the tiny holes. So as you can see on the right, there is an illustration of this setup. So the yellow part is the one that I'm saying that this one contains the mesh that has been coupled with the ultrasonic element, the piezoelectric element. So how does this vibrating mesh type all work together? So as you can see on the image, there is a medication on top of the mesh that has been coupled with the piezoelectric element. So as the piezoelectric element is vibrating, this vibration is also transferred to the mesh because you need to vibrate as well. So these vibrations force the liquid medication through the tiny holes, and actually this process breaks up the liquid into fine droplets and then creating the mist itself. So this is actually how the vibrating mesh type nebulizer works. While on the static mesh type, so this type of nebulizer uses just a static, or we can say a stationary mesh to generate the mist itself. So in this type, the mesh is not coupled with the piezoelectric element. So on the image, you can see that the mesh is separate from the piezoelectric element. So instead of the vibration being together with the mesh, they are actually separate. So as you can see, the part that I've labeled liquid drag is the one that receives the vibration. Then when it receives this vibration, it is then pushed through the static mesh. So this mesh, as I said, it has tiny holes. So as the liquid is passing through this mesh, it generates the fine particles themselves. Right. So that's how the static mesh type works. So just to explore the advantages and disadvantages on the advantage side, they are quite in operation because they don't use all right, so because they don't use a compressor, they are not loud. They are quite in operation. But on the disadvantage side, the mesh nebulizers need regular cleaning because the tiny mesh can easily get clogged. So a user is required to regularly clean these meshes. So that's one of the disadvantages. All right, so right now I will now hand it over to the host to take us through the poll questions now.
All right, so now we are able to answer one of the poll questions. If you're not able to access or you don't know where polls are, it's under the activities. So just go under activities and check the polls, and then you'll be able to check the poll and provide a reply. So the first poll is, which of the following is the major component of a jet nebulizer? There's compressor unit, mask, both, not sure. So we'll just wait for a few seconds to allow people to vote, and then we'll check the result. There's also another poll that has just gone live, and it says, jet nebulizers are associated with noise. False, true, maybe. And we have another one that reads, Which component of the ultrasonic nebulizer is responsible for converting electrical energy into mechanical vibrations? Control board, piezoelectric transducer, fan, or air filter? Okay, so for poll number 1, which of the following is a major component of the jet nebulizer? Load got it right, it's the compressor unit. Okay, so for poll number 2, jet nebulizers are associated with noise. That's true. Got 8 votes. For poll number 3, which component of the ultrasonic nebulizer is responsible for converting electrical energy into mechanical vibrations? That's a piezoelectric transducer. All right, so we'll answer the next polls after Claudia, who is our last presenter for the day. Thank you.
Thank you very much. So I'm going to take you through the maintenance of the nebulizers. So I'll just take you through the common faults and problems, the possible causes, and the possible solutions that you may apply. So the first problem that is common is that you might have no nebulization or low nebulization rate. So this might be because of your worn out compressor, that's for jet nebulizers, a transducer, that's for the ultrasonic nebulizers, and the mesh itself might also be worn out for the mesh nebulizers. So if the compressor is worn out, that means it won't be able to produce the recommended pressure to produce or to form the aerosols. So you need to repair your compressor. It might be that you need to repair the motor itself, or the piston might be loose. So you need to repair your compressor because the recommended pressure to produce the aerosols is 30 to 50 psi, as mentioned earlier. And for the transducer, it might be worn out and not able to convert the electrical signal to the vibrations that are recommended to produce the aerosols as well. And as mentioned by my colleague, the mesh might be clogged and will not able to produce the aerosols as well. So you can either replace these components or just service them. Another cause for low nebulization that may have clogged filters. So I'll show you clogged filters in my next slide. So if the filters are clogged, that means the amount of air that's passing through the filters is going to be low. And this will affect the overall performance of your compressor, since the pressure might be low and you have low nebulization as well. And for the filters, they need to be replaced. So you just need to replace the filters when you see that they're dirty. And you might have that the baffle is not placed in the medication cap, or it's incorrectly positioned. So as mentioned by my colleague earlier, that depending on the cap that you have, either others have fixed or removable baffles. So for the removable baffles, if it is not placed or positioned correctly, that means you affect the rate of nebulization or the whole nebulization in general. So we just recommend that you need to place these correctly and make sure they're placed correctly before you start your treatment. And you might have loose tubes or the hose might be loose. So this will affect the general performance of your compressor in terms of, or your nebulizer rather, since the pressure would be low or you have leakages. So this will affect the delivery or the performance of the nebulizer. So for this, you just need to check the leakages. So to check the leakages, you can use soapy water for this. So the first picture is, these are like the clogged filters I was talking about in the previous slide. So you need to just replace these. They don't need to be cleaned or anything. So just need replacement of these filters. And this is the compressor unit. So the pipes might be loose. So you need to check for these pipes, or they're bent. Make sure they're not bent because to affect your nebulization. And this is a vein, where the arrow is pointing. This might also be worn out, so it might need to be replaced as well. This is the setup I was talking about. This is for a removable baffle. So if the baffle is not placed correctly, that means it will affect your nebulization in general. So the next problem that we'll look at is the device might be abnormally loud or high pitch noise. So as mentioned, the jet nebulizers are generally associated with noise, right? But then this noise we're talking about is abnormal or high pitch. So the possible causes for this might be misalignment of your components. So this misalignment of the components I'm talking about is in the nebulizer or the cap itself for the removable baffle that we just saw in the previous slide. This might cause noise. And then if the compressor is worn out, it might be more louder or might produce high-pitched noises compared to when it's properly functioning. And also for the transducer, it might have the transducer that's worn out might also cause high-pitched noises. And if the mesh assembly is also not properly positioned, it might affect the noise and cause a high-pitched noise. Also, excess medication in the cap might cause the high-pitched noises. So most of the caps have measurements of the units. So you just have to follow the measurements that are labeled on the cap. And the solution for this is you can service your compressors or make sure that the compressor or the transition, the mesh are functional, as well as proper placement of the components. The next fault that we'll look at is that you might have no power on your unit when the power is switched on. You might have, for AC power, you might have electricity coming on from your socket, but not reaching your nebulizer is not switching on still. So this might be because your AC cord is not connected or it's faulty. So you just need to cross-check and just troubleshoot where your power is breaking. So this may just need to replace your cord if it's faulty. For those that use batteries, maybe that your battery is drained or your battery is expired. So you can recharge your battery or just replace the battery overall. And you might also have loose connections. So these loose connections, as mentioned, so especially for the ultrasonic nebulizers that have the power circuit board, you might have loose connections. So you just need to cross-check for those connections as well. And it might be that your whole circuit board or the components on your circuit board are burnt out. So you can troubleshoot for those components, either replace them or replace the whole power circuit board overall. Another common problem is overheating. So this is associated with usually with the jet nebulizers, where if the compressor is covered, you might end up overheating the system because there's no cooling mechanism there. As well as if the device is being used longer than the recommended time. So this is like overusing. So with time, obviously the device will start to overheat. So you just need to follow the manufacturer's instructions on the duration of use. And also make sure that you don't overuse it on the patients, just need to use them as recommended. So I'll just take you through the last slide, which is safety practices for the nebulizers. So the first one is do not place the compressor near or near liquid. So this is because this is a safety reason, as the title says. So you need to make sure that you're not, when maintaining or operating these nebulizers, the compressor is not near the liquid, because this will cause it can cause electrical shocks or damage of the compressor. And also you need to wipe the compressor with a damp cloth. So this point is related to the first point, because this might damage your compressor if you use a wet cloth. So you just need to use a damp cloth. And also, as I mentioned, that the filters, so you need to check the compressor filter monthly or replace it when it appears dirty or discolored. So you can see this from the previous slide that I showed you on dirty filters. So these don't need to be cleaned or washed. They just need to be replaced, even if they don't appear dirty. But if it's after a month, you just need to replace them. And also you need to clean the unit or the nebulizer using a vacuum or compressed Yeah, so there's some components that don't need to be in contact with water. You just need to use a vacuum or compressed air. And there's some components that can be cleaned with liquids. So you just have to take note of that. And also ensure that there's sufficient cooling water in the water tank. As mentioned earlier by my colleague, that this cooling water helps to cool the piezoelectric elements. So if the water is not sufficient, that means it will affect the medication delivery overall, because the medication do not need heat, as mentioned. And also you need to assess power cords and loose connection, because this might endanger the users or engineers when you're servicing the code. So just need to make sure that you don't have these loose connections or extruding wires. So this is all we had for you today, and I'll hand it over to the host to take us to the poll question.
Thank you so much, Claudia, for the presentation. Thank you, everyone, for the presentation. Victor, wait, it was very wonderful. Okay, so the poll question is, which of the following faults have you mostly encountered on a nebulizer? Low or no nebulization, power failure, overheating, high pitch noise, none of the above. So we'll give 30 seconds so that people have a chance to respond. Okay, I can see that the votes are still coming in. While people are voting, the floor is now open for questions and comments. So feel free to raise your hand or type questions in the chat, and I'll make sure to acknowledge you and provide an opportunity to ask. So bring on those questions for our engineers. So as we're waiting for questions, we can go and then check this poll. As I said, polls are under the activities tab. So the poll question is 4 p.m. a convenient time for you to attend the webinar? If not, please indicate your preferred time. So this will help us, so please give us the feedback, and the poll is live. If anyone has questions, please ask questions and we'll be here to respond to them. As we're waiting for questions, I have a question for our engineers. So for the jet nebulizer, instead it just uses a compressor and a nozzle. This is similar to like what an oxygen concentrator has. It has a compressor. And there's some oxygen concentrators that just use the medical air from the compressor to also have a nebulizer. Is this something that you know of, or can you, or it's not done? Or can more light be shed?
Hi, Daphne. Yeah, so yeah, it's true that some oxygen concentrators have nebulization functions. So there's actually a port for atomization. Yeah, so just to answer you in short, yeah, it's possible on an oxygen concentrator also.
All right, thank you. Okay, so we'll read a new poll is live. So it says, did the webinar meet your expectations? Did it exceed expectations, just meet them, somewhat met expectations, or did not meet expectations? So please respond. And if you have any comment or suggestion, they're welcome. You can raise a hand or type them in the chat. So as we're waiting, I'll read the result for poll number 6, which was, which of the following faults have you mostly encountered on a nebulizer? And I see that most of you have said that low or no nebulization. And the second most common problem is power failure. And a few just have overheating, high pitch noise. So yeah, thank you for responding. Okay, I've seen a question in the chat. It says, I always don't get the training materials after the training. Why? So we post our videos on YouTube. We have a YouTube channel called Oxygen Alliance, and if you go there, you find this video and other videos that are posted. So just check the YouTube page and you find these videos. Okay. The other question is, what would be the main cause of the nebulizer's low power?
May you please clarify the question when you talk of low power?
Okay, so Attilio, may you please clarify on low power? And I saw that someone raised a hand. May you please raise it again? I didn't have a chance to see. While we're waiting for the clarification, we have a question. Are we supposed to use normal water or distilled water? Is it in order to use normal saline? May another engineer take this, please?
All right, so for the question on whether we are supposed to use normal water or distilled water, it is recommended to use distilled water for the water tank in the ultrasonic nebulizers. So yeah, but as you have asked, is it in order to use normal saline? So on that, what I would say is it's recommended that you use distilled water.
All right, thank you. We have another question from Dixon, and it says, is it okay to use a concentrator for nebulization, especially the ones that do not have a dedicated port for nebulization? So I'll ask any engineer to take this. Okay, Adilio, I see the link to the materials will be posted. Please just wait a minute. We'll post a link soon. Any engineer to take the question on whether concentrator can be used for nebulization if it does not have a dedicated port. Victor, we can't hear you if you're speaking.
Okay, sorry for that. For the question that is asking, is it okay to use a concentrator for nebulization, especially the ones that does not have a dedicated port for nebulization? So the recommendation is that it is not recommended to use that because the nebulization port and the oxygen outlet port to the patient have two different pressure ratings. So the pressure rating for a nebulizer is not the same as the pressure of oxygen that is going to the patient. I hope that answers the question.
Okay, thank you for that. Because of time, we're taking our last question from Elson, which says, want to know is it possible, if medication, sorry, may you please retype that question so that we're able to answer it? Okay, Elson, you can ask the question.
On possible problems, I see a certain problem when you say if the medication in the mask is excess, what would be the possible solution? I don't hear it clear.
Okay, may we please have a response from the engineers?
Okay, I hope you can hear me. You mentioned that if there's excess medication in the cup, not in the mask, but the nebulization cup, where you put your medication themselves. So these cups have measurements. So you have to follow those measurements. You don't have to exceed the measurements that are written on the cup. So that's the solution. It's not in the mask, but it's the medication that you put in the nebulization cup. I hope that answers your question.
Okay. Unfortunately, our time has run out, but I can see that there are still more questions. You can drop your question in the chat and also drop your email so that we respond to you and then we're able to answer your questions. We'll send you an email with the response. If there are further questions, you can email us at info@oxygenalliance.org. This marks the end of this call, and thank you to our OpenO2 engineers and Oxygen Alliance engineers for the wonderful presentation. It has been an educative session, and thank you all very much for attending and for answering the poll questions and for being an active audience. Bye. Goodbye.